There are many ways to make money online, and one way is to sell your knowledge. Maybe you have deep expertise in a certain topic, or you just have a unique perspective. So you decide, you know what, I'm gonna write a book, film a video course, or do both. Then you go to a course hosting platform and you upload your content, and then you start selling. Now, this approach works. However, as developers, we always get this urge of wanting to build our own solutions. This is me acting on this urge. Now, to not fall into the trap of building my own course platform and never releasing my course, I give myself a deadline: 1 weekend. 1 weekend to build the following features. Users should be able to view free content on my website. This way, they can be familiar with my style and know what to expect with every piece of content that I publish. They can also see the landing page for my course, click buy, which redirects them to a checkout page where they can enter their credit card info. They can then use the same email that they used during checkout to log in into the platform and to view protected content. Now, to build this project, we'll be using a lot of tools. The first one is Next.js. Now, in case you don't know what Next.js is, it is a full stack framework that has a fantastic developer experience. It allows you to build your front end using React and makes it super easy to build your API. It has a file-based system router, so each file in the pages folder is automatically a route. There's also support for dynamic routes. So for example, when you're building a blog, you want a page that shows each individual post. Now you can have a page that displays different content depending on the URL params, which is super neat. Now to build your API using Next.js, each file in the pages/API folder is automatically an API endpoint. What's also cool is that when you deploy Next.js, each one of those endpoints is automatically a serverless function. So this way, you can scale your app very easily without you needing to do much work. Now, the final feature that we'll be leveraging when building this course platform is static generation. Next.js supports different data fetching strategies. You can fetch data at build time. So this way, you can serve your users just static HTML, which is super fast and can be cached. There's also server-side rendering. So with each request, the page gets rendered on the server and then sent back to the user. This is great for SEO. And you can also do client-side rendering. So maybe you have a page where it's not super important for data to be kept up to date. Maybe it's like an admin dashboard. It's fine if you just show some loading spinners. Now for the course platform, we'll be kind of leveraging all of these depending on the type of page that we want to display. So yeah, but the main focus is on static generation. Now, since I have control over my platform, I don't just want a regular blog. I want a blog with interactive components. And this can be done by using MDX. MDX is the markdown for the component era. It allows you to embed JSX code in your markdown files, and this JSX actually gets rendered. So you get the awesome authoring experience of writing markdown, but at the same time, you can have interactive components in your blog posts. Maybe it's a data visualization or a component where readers can tweak values. Like, the possibilities are endless. This can help you craft a better user experience where they can develop a deeper understanding of a certain topic or help you communicate your ideas better. Now, to add support for MDX, I'll be using Next.mdx Remote. Now, the way it will work is that I'll have a folder in the root folder of my project. It's called content. And inside it, there are 2 folders. One that will contain the public posts, so like my blog, and another folder that will contain the lessons that will be behind the paywall, where users have to pay so that they can log in, so that they can view them. Now, in the pages folder, I have a file called blog.tsx, and this file is responsible for rendering the page where I'll be displaying the list of all blog posts. So the way it works is I'm using getStaticProps, and I'm just fetching all posts from the file system, and I'm passing them as props. And then what I'm doing is just mapping over all the posts and displaying them one by one. So I'm showing like the title, the description, and then the categories. Now for the individual blog post, the logic is actually almost the same. I'm using a dynamic route. So I have a folder called blog, and inside this folder, there's a slug.tsx file. And in this file, I'm also using getStaticProps, but the difference is I'm grabbing the slug from the URL params and then just, getting the data for the requested blog post. And this way we have just a blog. This blog is just public right now, and anyone is able to just view the content and is built using MDX. So we can embed here just React components if we want. Now, when it comes to styling, there are a lot of options out there. You can use CSS files, you can use Sass, you can use a CSS framework like Bootstrap, you can use CSS and JS like stock components, or you can use a utility-first framework like Tailwind. Now, personally, I'm a big Tailwind CSS fan, and in case you're not familiar, here's how it works. You build your UI by combining utility classes. Now, a utility class is a single-purpose class that just does one thing. So for example, you can have a class that adds margins, a class that adds border radius, a class that adds box shadow, and just so on and so forth until you just cover all CSS properties. There are many. Now, in the beginning, my experience with Tailwind wasn't smooth at all. I've been using CSS and JS for a while, and just seeing how Tailwind worked was like, oh, I need to learn a lot of stuff, and like, they're ruining my HTML. But after I've actually, gotten used to the API, I've gotten so much more productive. And this is for multiple reasons. So the first reason is I don't need to worry about naming classes anymore, because sometimes I just sit there thinking, okay, how should I name my classes? Also, onboarding is there's no onboarding. So if I see a project that uses Tailwind, I can just immediately contribute because I'm familiar with the API. There's a convention. And the final thing, and to me, this is just one of Tailwind's best things, is that it has great defaults. So out of the box, you have a design system. This means you have consistent values for things like margin, padding, font sizes, colors, and just everything. But at the same time, there are no constraints. Like you can configure like everything. You can configure the generated classes. You can configure like the values. It's just super flexible. And to me, I don't see myself writing CSS any other way. So now that we have a working blog that has support for interactive components, thanks to MDX, and the styling and taken care of using Tailwind, now it's time to add authentication. And for that, I'll be using Next.Auth, which is an open source solution that just makes it super easy to add authentication to Next.js apps. There's support for many authentication providers, so you can log in with Google, GitHub, Facebook, Twitter, Discord. Most likely Next.Auth has it or eventually will add it. You can also bring your own database, so you can have support for session-based authentication. And then finally, what's super cool is that there is support for passwordless authentication using magic links. So a user will enter their email, they'll be sent an email with a login link that they can use to access the platform. And this is exactly what I need. Now, to set up Next.Auth, we're going to create an API endpoint that handles all of the authentication logic for us. So things like signing in, signing out, sending emails to users that contain login links so that they can log in, handling other authentication providers because we can have multiple ones. So to do that, in the pages/API folder, we'll have a new folder called auth. And in this folder, we'll have a file where we configure Next.Auth. In this file, what I'm doing is first importing Next.Auth from Next.Auth, and then I'm doing a default export while calling Next.Auth, and I'm passing in a configuration object. I'm then specifying a providers array. This is an array of authentication providers for signing in. So you can actually have multiple ones when you include them in this file. So you can have a GitHub provider, you'll import it and then include it. And you also need information like the client ID and the client secret. Now for setting up passwordless authentication using email, Next.Auth has two requirements. The first one is to use an email sending service so that we can actually send the emails that will contain the login links. And we need to have a database. Now for the email sending service, you can use whatever service you want as long as it supports the SMTP protocol. This is the protocol used for sending emails. So for me, I'm using Twilio's SendGrid, and I just created an integration and specified that it's SMTP. And I grabbed the following information. So I got the host, the port, and then created a new password and just passed in the username. I also specified a from email. I used like my own personal email, but for example, you can use like noreply@yourdomain.com. Now, so far, authentication will actually not work because we haven't included a database yet. So we're going to do that first and then come back to this authentication portion. When it comes to working with databases, I've always been intimidated by them. I started out as a front-end developer, so this layer of the stack was just so abstract to me. Which database should I pick? what are the differences between each database? How do I actually work with these databases? And how can the design of my database evolve over time? I had so many questions and things were very confusing to me until I started using Prisma. Prisma is a next-gen ORM that makes it easy to work with databases. Now, if you're not familiar with what ORMs are, ORMs, object relational mappers, allow you to use a programming language to work with a database. This is instead of using the database's native querying language. Now, the added benefit is that you don't need to constantly context switch between two different languages when you're building your backend. So, for example, you're writing your business logic using JavaScript or TypeScript. You don't need to now I need to think in SQL, for example. You can just write more code. And this makes you more productive. Plus, since you're working with a programming language, the editor is on your side. So things like auto-completion, type safety, you can have just comments, and the overall developer experience when working with ORMs is better than just using the database's native querying language. Now, Prisma has support for different database providers. There's support for Postgres, MySQL, SQLite, Microsoft SQL Server, and there's MongoDB, which is in preview. Now, which database I'll pick, I'll go over that in a bit. But first, let's add Prisma to the project. The first thing you need to do is install the Prisma CLI as a development dependency. So to do that, just run npm install Prisma and --save -dev. And after that, you can use the Prisma init command, which will set up a basic Prisma project for you. So just run npx Prisma init, and in the root folder of your project, you'll find a newly created folder called Prisma with a schema.prisma file in it. This is where you define your data model and design the schema of your database. Now, this file is written using the Prisma schema language. So to actually get things like syntax highlighting, auto formatting, and auto completion, make sure that you install the Prisma extension for VS Code. Now, again, the reasons we need a database is A, to store the information for users who purchase the course, and since it's a requirement for having email authentication using Next.auth. Now, thankfully, Next.auth has an adapter for Prisma that makes it seamless to have session-based authentication and to just add support for logging in with email. The first thing we're doing is we're defining a user model. Now, a model in your schema.prisma file will be mapped to a table in your database. Now, we're going to have a table where we have all users, and each user will have the following fields. So a user will have unique ID of type string, and this will be randomly generated for us by Prisma. Each user will also have a name and email, both of type string. Both are optional. That's because we have this question mark. However, the email has to be unique. So we can't have two users in the database with the same email. Then we have an email verified field, which is used to determine when the user verified their email. There's also an image field, which is, again, a string of type string, and it's optional. And so this is so that the user can have a profile image. And then finally, we have a field called accounts, which is an array of type account. This references the model account. And then there's a field called sessions, which is an array of type session, which is also another model that we have down here. So what we're saying is a user can have many accounts and they can have many sessions. Now, the reason a user can have many accounts is because, say, for example, we added support for logging in with GitHub, logging in with Google, and logging in with Twitter. If a user uses each one of those authentication providers once, an account will be created for each one of them. And we want all of these accounts to be associated with one user. And Next.auth takes care of that. Now, the reason a user can have many sessions is, well, so that they can log in multiple times in the platform. For the database, I decided to go with PlanetScale. It is a serverless MySQL database that has built-in support for Prisma. Now, the fact that it's a serverless database means you won't run into the connection pooling problem. This is a problem you face when using serverless functions, like Next.js API routes, to access server-based databases. What happens is that each request opens a connection to the database. So during traffic spikes, you quickly exhaust the database's connection limit. This leads to failed requests and slow performance. Now, PlanetScale introduces a unique workflow when you're working with databases where you have different branches. So the way it works, you have your main production branch. And whenever you want to update this branch's database schema, you create a development branch apply the changes to this branch, and then you make a deploy request. This way, you actually have non-blocking schema migrations, and your database won't slow down during the migration process. Now, I went to PlanetScale, created an account, and created a new database. Then, in the database settings, I checked the automatically copy migration data and picked Prisma as my migration framework. After that, I promoted the main branch to production. Now, I'm going to use Prisma Migrate, which is part of the Prisma ORM, to actually create the tables in my database. And what's also cool about Prisma Migrate is that it keeps your Prisma schema and your database schema in sync. Locally, I'm going to use the PlanetScale CLI to create two development branches from the production branch. I'll do that using the pscale branch create command. I'll call the first branch initial setup and the second one shadow. The shadow branch is needed to make Prisma Migrate work properly. Then in two other terminals, I'm going to connect to these two database branches by using the pscale connect command. I'll also add two database connection strings to my .env file so that Prisma can connect to each one of those database branches. Now, PlanetScale doesn't support foreign key constraints, so we have to specify in our schema.prisma file that we don't want to generate any. So first, I set the provider to MySQL, and I also added a shadow database URL which will be loaded from my .env file. And then I enabled the referential integrity preview feature flag, and in the data source block, I added the referential integrity property and set it to Prisma. And now we can actually create our migration. So in a third terminal, run npx Prisma migrate dev -- name to name our migration. And since this is the first one, I'll call it init. As you can see, a migrations folder has been created for us, and we can see the generated SQL. And now the next step is for us to create a deploy request. So to do that, we'll just run the pscale deploy request command. And if we go to PlanetScale and we refresh, we're going to see an open deploy request. So all we need to do is add changes to deploy queue and wait for it, and it will be deployed. So now I'm back in the file where we're configuring Next.auth, and I made a couple of changes. So the first thing I've done is I installed Prisma Client. Now Prisma Client, which is part of the Prisma ORM, is an auto-generated type-safe query builder. So that's what we'll actually use to send queries to the database. Now the next thing that I've done is I installed Next.auth's Prisma adapter. And in Next.auth's configuration object, all I did was just say adapter, Prisma adapter, and I created a new Prisma Client instance by saying const Prisma equals new Prisma Client, and I passed it to the adapter. Now, the next thing that we want to do is actually check, okay, is the users that's trying to log in my database? If they are, then we'll send them an email with a login link. Otherwise, we won't send them anything. So to do that, we have a function called send verification request, and we can add our own logic here that sends a query to the database. And for that, we'll be using Prisma Client. Now, all I need to do is just say const user equals await Prisma dot, and if I hit Control space, I'll get autocompletion from VS Code. And what I see here is actually coming from my schema.prisma file. These are my models. So I can just say .user dot and hit Control space again, and I can see the different available functions that I can use. Now, these are functions for doing CRUD operations, so create, read, update, and delete. Now, what we want is to find a user by their email. So to do that, I'll use the find unique function. So now next to it, I can actually see how to use it. So what I need to have is an object with, and specify a filter by saying where, and then have an object. So let's do that. So I can just say find unique, do an object, hit Control space, and this says where, and if I hit Control space again, I can see that I can filter either by the ID or the email. That's because both of these fields are unique. Now I'm going to say email because this is coming from the front end, like from the identifier right here. And what I need to do is, okay, check if this query returns a user. If it doesn't, then we'll just return and not execute the logic that actually sends the email. So all I need to do is just say if not user, we will return. And that's it. We've added logic that checks, okay, did this user purchase the course or not? Now, the next step is for us to add support for payments. And whenever a user pays, they will be somehow added to the database so that when they try to log in, this logic will execute and they'll be able to access the protected content. Now, to be able to accept payments from users on my website, I'll be using Stripe, which is an online payment processor. Now, what's cool about Stripe is that it has developer-friendly APIs, but most importantly is that it gives you a hosted checkout experience out of the box. You don't need to mess with credit cards, credit card validations, and it just saves you a ton of time. Now, to keep things simple, I'll only have one product. So I already am logged in, and I'm just going to go to my dashboard. And in the products tab, I can see that I already have a product. Now you can add a product where you specify all the details, like the price, and maybe even accept recurring payments. I'm just going to make it a simple $5. So now I'm on the landing page for my course. And when I click buy now, what happens is I send a post request to an API endpoint where we're creating a checkout session. Now, if I go back to my pages/API folder, I have a file called checkout.ts. And this is just straight from Stripe's docs. And we're defining a serverless function that creates a session for us. So what I have is the price, and this price comes from my dashboard. And yeah, we're creating a session, and we're specifying the payment method types and the mode, and what happens on success and what happens when canceling. So for example, we can just say, okay, when the payment is successful, we can direct them to a page that says, yay, you bought the course. And we can create kind of like an onboarding experience. And yeah, this is how simple it is. Now you're going to need the Stripe secret key, which also you can find in your dashboard. And that's it. Now, the final piece of the project is, in the event of a successful payment, we want Stripe to let us know the info of the user that just paid. So this way we can grab that info and save it to the database, and when the user tries to log in, they'll be able to log in and access the protected content. Now, this can be done through webhooks. Now, to configure webhooks, in your Stripe dashboard, there is a developers page, and on the left, we have a webhooks tab. Here, you can specify which type of events you want to receive and where Stripe should send them. Now, all you need to do is you click Add Endpoint, and you have one of two options. Either you specify the URL of your API endpoint, like the deployed version, or you can test in a local environment using the Stripe CLI, which is super nice. And now what you want to do is actually select the different events that you want to listen to. And for us, the ones that we're interested in is the charge succeeded. Now, I don't need to do all this stuff because in my app, I already created an API route and I called it webhook. This will be the endpoint. And I created a deployment to Vercel so that I can actually test this. And if I actually go to this endpoint right here, this is the hosted endpoint, I can see a log of different charges. So I can just see, okay, some of them failed, some of them succeeded, and I can click individual ones and I can find just all of this information. And for us, the most important info is the user's email, which we can find here. It's called officialcampo@gmail.com. So this is super nice. Now, there's one final thing. We want to secure our API/webhook endpoint. That's because anyone can just send us an event saying hey, I paid for this. So we want to make sure that the event is actually coming from Stripe. And this is done by including a signing secret in the request. And in the logic, which we'll look at right away, we will have a check that checks, okay, is the secret included in the post request that we're receiving? If it is, then this event is actually coming from Stripe. So now I'm in the /API/webhook file, and here's what we're doing. So I imported Stripe, and I also imported micro. This is going to be used for parsing the request because by default, Next.js does body parsing. So we are actually disabling body parsing by Next.js and doing it ourselves because it needs to be parsed a certain way. And then we're also importing Prisma. And we're creating a new Stripe instance by passing in the Stripe secret key, which is coming from our .env file. And we're also specifying the API version. And then we are just setting the webhook secret to the Stripe webhook secret, which also comes from our .env file. Now, in the handler function, the first thing we're doing is we're checking the request method. We want to only receive post requests. We don't want someone to just, send us a GET request. And what we're doing is we're saying buff equals await buffer request. So like this is so that we can parse the request, and then sig for signature equals request.headers, and then the stripe signature. And what we're doing is we are actually constructing the event using 3 pieces of information. So the parse request, the signature, which is included in the like the request itself and the request headers, and we're also passing in the webhook secret. So this is now the event. And what we're doing is we're checking the type of the event and making sure that it's HR succeeded. And what we're going to do is actually write a Prisma client query to save the user to the database. So if I actually expand, what's happening is I'm grabbing the charge. So it's event from like event.data.object, and I'm just doing a Prisma client query. So I'm saying await prisma.user.upsert. So upsert, what it does is that it creates a new record in the database. And if there is an existing one, it won't throw an error because we can't have 2 users with the same email. And also, this way, we can accept payments multiple times from the same user, which is cool. So what we do is we're saying await prisma.user.upsert, and we're saying create. So if we don't have a record where the user with like the email that's coming from charge.billingdetails.email, we're going to create. But if the email already exists, we're going to just update the email. And if we have like other fields, we can also update them here. And where? Because we're finding by the email. So that's really it. And then I'm just saying res.status200.send, this works. So this is our course platform. And that's it. You just saw how to use a bunch of tools together to build a really cool project. Now, maybe you don't want to build your own course platform, and that's completely fine. To me, what's important is that you see the full picture and you can see how the different pieces fit together. Maybe you're a front-end developer and you've been curious about doing full stack development. Well, using Next.js plus API routes along with Prisma and PlanetScale is a great choice. Or maybe it's the opposite. Maybe you're a back-end developer and you're looking for a great front-end framework. Using Next.js makes a lot of sense. Now, there's a reason that I picked these tools. All of them offer great developer experience, and at the same time, they have great developer communities. So if you have any questions, if you run into an issue, if you want to ask for help, you'll find someone to help you. And to me, that's just super important.